hypothesis testing, specifically type 1 and 2 errors. And in this example, we're going to be using the binomial distribution. So we have a lot of elements that are coming together in this lecture. So the example here is that a quality control engineer randomly samples 12 parts from the production line to ensure the proportion of defective parts is less than 10%. The inspector is going to conclude the proportion of defectives is less than 10% if one or less defective is found. The question here is, what is the probability of a type 1 error? For this example, we need to go back, and we need to go back to writing out the statements of the null and the alternative. Remember, the null hypothesis is always a statement of equality. So that means the null is that the proportion of defectives is 10%. The alternative is what we hope to establish with this data. We hope to establish that the proportion is less than 10%. So we've stated our null, we stated our alternative. Here, it's wise to write down what your random variable is. Your random variable here is the number of defective parts found in the sample. The sample consists of 10 parts. Okay, so these 10 parts are either defective or not, so true or false, and we're going to assume here that the probability of defective remains the same throughout as p, so this is a binomial distribution. One more very important thing is that in this problem, they give you the rejection criteria. They're going to conclude that the proportion of defectives is less than 10%. That's the alternative statement. If one or less defectives is found, i.e. if x is less than or equal to 1. So the probability of a type 1 error is the probability we reject the null when the null is true. Well, rejecting the null means x is less than or equal to 1. That's our criteria. When the proportion is 10%. Okay. So here, and one minor correction is it's 12 parts that are randomly sampled, not 10. Okay, so I think I said 10 instead of 12 earlier. So here, if we want to calculate this probability, we just need to use the binomial distribution and calculate the probability x is 0 and x is 1. We can do this with the cumulative distribution function, and we need to write out what the binomial distribution is. So here the binomial, the number of trials is 12. That's how many are taken in the random sample. The probability of success on a single trial comes from the null hypothesis. We're told that here the null hypothesis is true. The null hypothesis is that the probability of defective is 10%. The value of the binomial distribution we're going to calculate is 1 or less, so k equals 1. So the type 1 error here is just this number calculated by this binomial CDF, and it's 65% is the probability of a type 1 error. Okay, so moving on, another type of error that can occur is called a type 2 error. So here, a quality control engineer randomly samples 12 parts, same as before, and they want to establish that the proportion of defectives is less than 10%. The inspector concludes that it's less than 10% if one or less defective is found. However, in this scenario, the true population proportion of defectives is 5%. We want to calculate what's the probability of a type 2 error. So here, the true population proportion is 5%. Okay, and one thing I need to change here is this should be 0.05. Okay, so a type 2 error, the definition means you fail to reject the null when the alternative is true. Okay, um, so failing to reject the null means that your rejection criteria, which is that x is less than or equal to 1, is not met. Okay, so the opposite of meeting x being less than or equal to 1 means that x is greater than 1. And the alternative being true, we're told here that that means p equals 5%, 0.05. Okay, so we need to adjust this a little bit um, to be 0.05, and everything else looks good. Okay, so that's going to give us a probability of a type 2 error of 11%. And one more thing is called the power of a statistical test. How the power of statistical test is it's 1 minus the probability of a type 2 error. And what this means is that you correctly reject the null hypothesis when the alternative is true. So you can think of it as the probability you make the right decision. And in this case, it's 88% is the power. Okay, so thank you very much. Uh, that was just an example of type 1 and 2 errors with the binomial distribution.